Welcome to AASHTO Resource Q&A. We're taking time to discuss construction materials testing and inspection with people in the know, from exploring testing problems and solutions to laboratory best practices and quality management. We're covering topics important to you. Now, here's our host, Brian Johnson.
Welcome to AASHTO Resource Q&A. I'm Brian Johnson.
And I'm Kim Swanson. And who do we have with us here today, Brian?
Well, a couple episodes ago, we covered the soil proficiency sample results, and I thought that was pretty interesting for our listeners. We have so many proficiency sample participants all over the world, and I think the discussions are relevant for them. So we have invited back John Malusky, the manager of the proficiency sample program here at AASHTO Resource, along with Pete Holter, senior quality analyst with the AASHTO Accreditation program, to talk about the latest rounds that have just come out in July. That would be the Asphalt Mixture Hveem Design samples, the Asphalt Mixture Marshall Design samples, and the Asphalt Mixture Gyratory samples. So welcome to the podcast once again, John and Pete.
Thanks, Brian and Kim.
Yeah, thank you. Good morning.
Yeah, for those listening, John was the first one and Pete was the second one. So you can follow along as we have our discussion. So, John, what is interesting? Let's take it one by one. What was interesting this time about the Hveem design sample?
Actually, the Hveem sample was one of the more normal, if you want to call it that, samples that we've had come out. Everything was pretty standard. The voids were a little bit lower than we had anticipated with our mix design. And that also trended through the Marshall and the Gyratory. But overall, it appeared to be a fairly normal round. Nothing really crazy other than, like I said, the void content or air void content was a little bit lower than what we had anticipated.
Okay, so the distribution looked pretty typical.
Yep. Yeah, it was almost every single test property in the scheme was normally distributed, and it looked like a pretty good round overall. Like I said, the only surprising thing was the void ratio was just a little bit lower than we anticipated in our designs.
What do you mean by the air void distribution about that, John? So what does that mean that they were lower than you anticipated?
So when I did the mix design work for the Marshall Hveem and the Gyratory, I usually try to target a specific air void ratio in the compacted specimens based off of typical mix designs. Try to vary the air voids between different years, changing specimen heights to give a little bit of variety in the samples and not, be complacent when we do the design work. And my target air voids were a little bit higher than what the grand averages of the participants. I think the Hveem, we were shooting around 3.5%, closer to 4%, and the laboratory's averages were around 3%. So it just changed a little bit, which is fine. I mean, it is what it is. So, things happen. Not that I'm correct by any means.
I was going to ask, what does that actually mean? So you didn't do something wrong and the labs didn't do something wrong. It just happened to be different.
Yeah, it's just variability. So when I look at the rounds, like I said, I try to do my best to test as diligent as I can and use our equipment that's within specification. But things change, right? So my goal, Kim, whenever I do any of these, is to look at the final results from all the participants and then essentially score myself and assign myself a Z-score and a rating and see how well I held up to everybody else. And my ratings were a little bit lower this year. So I'm putting the onus on me.
Okay, well, that's interesting in itself, but the Hveem is pretty complicated because we've got 3 different compaction methods, right, going on. Do you think that might have so for those of you our international listeners, I don't know if you even know what the Hveem is. There are only a few states in the United States that use it, and the ones that do present us with different compaction methodologies, totally different equipment, and I would guess that a 4-inch super paved gyratory in Colorado may produce a different result than the is it a 2-inch Texas gyratory specimen, and then you've got the California kneading compactor specimen, which is the traditional compaction method that then goes to this Hveem stabilometer. What do you think, John? You think that played a role?
Well, absolutely, right? If you have three different methods of compaction, you're going to have three different void ratios, right? You're applying a different amount of force to the specimens to compact them. So I think that's definitely going to be a change. The other thing is, right, all three mixture designs are slightly different, and the compaction temperatures. So each compaction effort has a different design with a different specimen mass requirement and different temperature requirements. So of course we're going to see some variability in it when it comes to the three different compaction methods. There's no doubt.
Yeah, now speaking of that, this is a self segue into the next question that I want to ask you about that round. I believe there's some changes coming down the line relative to the Veeam sample program, and there are elements of that that can be found on our website right now. Can you tell us what's going on there, John?
Yeah, that's correct, Brian. We have made the decision to separate the Veeam samples into three completely different samples. They'll still obviously be using Veeam stability for one of the metrics, but we're going to completely diverge the program into its three compactive efforts. So rather than having one sample round that's called the Veeam, we're going to have three separate sample rounds, and they'll be specified by each method of compaction. So we'll have one round that'll be based off the California kneading compactor, one round based off the Colorado method, and one round based off of the gyratory shear, or the Texas gyratory as people call it. The intent's to basically try to make it a little bit easier on our participants and on us, just simply with confusion with the instructions in the data sheets. Right now, all three efforts are lumped together. They're analyzed separately, but they're all confined in one data sheet and one set of instructions. And it just seems to be very easy to show or see confusion when we look at the data. It's pretty apparent that you can have laboratories who submit in the wrong light item. They'll see air voids and not recognize that they're submitting for the air voids for the Texas compactor instead of the air voids for the Colorado. So by splitting the programs apart into three distinct ones, we'll be able to hopefully reduce some of that confusion and make things easier on the participants.
Yeah, that sounds good. And I think one of the results, and we had communicated about this earlier this week, there was some data in the current report that's a little bit jumbled up, and that's your bulk specific gravity data. And my understanding is that in those new samples, we're going to have separate entries for the traditional bulk specific gravity using T166 or ASTM D2726 from the what is it called? The specific gravity, bulk specific gravity using
Vacuum
the
sealing.
vacuum sealing bags. Thanks. Vacuum sealing was escaping me. And their AASHTO method for that is T331. That split is going to cause a little bit of a difference in reporting unless we get more participants. And I'm going to ask Pete about this one because I've kind of excluded him from the conversation up to this point. But Pete, what did you find when you looked at the participation levels? What's the expected outcome going to be with those future reports where T166 and T331 are split out?
Yeah, at this point, our levels of participation, it doesn't look like we're going to have enough people submitting data for the vacuum sealing method in these programs. The Veeam program itself is a lot smaller than the Marshall program and the Gyratory program. Maybe like a third of the number of participants. John might know better, but so we have a lot fewer labs submitting data. The vacuum sealing method is already split out in the Marshall and Gyratory programs, and we have enough participants to be able to analyze the data for the vacuum sealing method. But in looking at how many labs we have accredited for the three methods of compaction included in the Veeam sample, and then the subset of those labs who are also accredited for the vacuum sealing method, doesn't look like there's going to be enough data to analyze those labs, especially for the Colorado compaction method. I looked at this yesterday, and there's two labs who perform the Colorado compaction and are also accredited for T331, D6752, the vacuum sealing methods. So 2 labs isn't enough.
No, definitely not. It kind of makes me wonder, since it's such a small number, if they just use really tight mixes in Colorado that don't have enough air voids to necessitate using the vacuum sealing method. Maybe they just don't get that much absorptions in the samples when they're done testing. Cam, you had a question.
So, John, when are these changes about the splitting of the Veeam sample going to be in effect?
So they will take effect for the 2023 sample year. We've already sent a notification out to all of our participants about the changes, and we're hoping to make it as seamless as possible. We're using the enrollment data from the current round that just closed and we just had that final report for, to make the separation between the compaction efforts. Working with our IT manager, we are going to try to make it as seamless and as smooth as possible. So that way the laboratories are automatically enrolled in those samples, and the only thing they will have to do is verify that everything is correct. And we went ahead and notified the participants of the change to the samples by sending all of them a letter through email and let them know that the change is going to take place and it should be seamless. And they should notice the change effective by the time we start our bulk billing. And the bulk billing for the following year for the proficiency sample program usually occurs in September. So hopefully around the 1st or 2nd of September, when we send the bulk billing statements out, the laboratories can go and confirm their enrollment. And if there are any changes, they can let us know so we can update their invoices appropriately.
So, Brian and Pete, what does this split mean for the accreditation of those things? I know Pete was talking about that a little bit, of how there might not be enough participants in some of those tests for reliable data. Does that impact the accreditation of any of our laboratories?
It should not have an impact on that. The test properties or the line items will essentially be the same, and that data should carry over from the old style to the new style. The only difference is going to be what Pete was talking about, where we don't have enough participants for T331, the vacuum sealing method, which means the data will be suppressed. Now, if the data is suppressed, that means that they don't get issued ratings, which means that there will be no possibility for a suspension for those laboratories, which I'm sure they'll be disappointed that there's no possibility for suspension. But really, it's like we can't really evaluate that anymore for accreditation purposes when there aren't enough participants. So that's really the only change. But it is a good change, because right now we don't know if they ran T166 or T331. Because that data is combined. That's correct, right, Pete?
Yeah, there are 2 separations we're talking about here. First, we're talking about separating out the compaction methods and all the associated tests for each of those 3 compaction methods, and creating 3 separate proficiency sample programs for those. And then within each of those 3, there's also a line item which in the past was a combination of results from 2 different tests in one line item. The bulk specific gravity without using the vacuum sealing method, and then the bulk specific gravity using the vacuum sealing method. And so now within each of these separate programs, we're going to also be separating that line item out into 2 separate line items, so the labs can actually submit the applicable test.
That makes sense. And John, will the historical data for laboratories and like their performance charts carry over with this new method?
Yeah, thanks for that question, Kim. It should. So we just went through this with the aggregate the aggregate degradation samples this past winter, and we were able to successfully transfer the data through so the performance charts were continuous. So we shouldn't see an issue with it, and I think we're pretty confident that the transition will be fine and all of the historical data will be maintained.
Yeah, that'd be great. And I am curious. I mentioned earlier, I don't know about our international listeners, if they ever use the Veeam stabilometer. I have no clue if that happens, but I'd be really curious. John, do you know? Do we have any international participants in the Veeam sample?
I'm going to take a quick peek now. I don't believe we do.
Okay. Yeah, and the Veeam was a homegrown American test from Francis Veeam, who used to be a Caltrans employee, and wrote an article years ago.
Yep, and I will link to that article in the show notes if people want to know more about him.
So I can confirm we do not have any international enrollments in Veeam. We have about 230 domestic, and that is it. We don't even have any in Canada.
Okay. One last thing I want to say about the Veeam article. After that article was published, I had a really nice conversation with Francis Veeam's daughter, who had read the article and called to talk to me about it. And I was so blown away that, first of all, that she even knew about it, but that she really appreciated that. That was probably the highlight of my my writing career. This is laughable to call it that. It was really kind of a neat thing. You never know who's going to read anything or listen to anything, and it's great when you get to hear from people who have, and especially if they liked it, then you feel good about it. But let's get back on topic for a second and talk about the Marshall design samples, though. So the Marshall is your traditional specimens that you pound with the Marshall hammer and test them for stability and flow. How does this round look? This is 77, 78. Should have mentioned that at the beginning too. 77, 78 for both Veeam and Marshall. Those are the even and odd samples for this round.
Yeah, once again, Brian, the sample distribution was pretty normal. The uncertainty of the assigned values was below the ISO recommended limits. So it was, once again, a pretty good sample, not a lot of random things that took place. Once again, just made the comment before, like with the Veeam, the air voids were a little bit lower than I anticipated with my design work. Stability and flows were right on those. That's always kind of interesting. Like, I run my sets of samples here and I get a void ratio right around 3 to 3.5%. The laboratories report 2.5 on roughly 2.5 on the average, but stability and flow values are basically the same. So I'm not sure how that works. I don't know if there's any insight there that maybe Pete could share that I'm not aware of, but it was a good round. Everything seemed to be pretty consistent. I didn't receive a lot of complaints or comments about the instructions and data sheets, so it seemed to be straightforward.
Sorry, I don't have any insights, but I'm curious if you do as to the trend in the number of participants in these three programs. Is like maybe the Marshall program shrinking while the Gyratory program is growing?
Yeah, so Marshall increased just less than 1%, which is pretty typical. Right around 1% is our normal growth. Veeam actually dropped about 5%, and Gyratory increased by roughly 1%. So usually 1% is traditional growth, just the way that the normal sample rounds work, due to picking up some international participation and based off of bids by jobs. I mean, I think the economy may have slowed down some of the work that was out there, so we didn't see any higher increases. But typically 1 to 3% is where our growth usually lies.
Is this an anomaly then for the Veeam sample to drop by so much, or are there any trends here over the years?
For the last few years, the Veeam has dropped by roughly 3 to 4% per year. But in the grand scheme of things, right, we're looking at 10 participants per year, so it's not a ton. But like I said, it fluctuates with the way things work with the economy and construction projects. So I'm not going to 100% say, Pete, that it's a transition away from it. Like I said, we're still over 200 participants, so it's still a very strong program.
Cool.
Yeah.
I think that's a good thing, though, too, if people are only participating in what they need. So they're not just randomly because they've always participated in this and they don't actually need it. Like, we don't want our customers to just enroll in things that they don't actually need and use, though. So I think that's a good thing if they don't need it and then they don't participate in it.
Yeah, Gyratory is probably one of the sample rounds where we see the biggest jumps. We had about almost a 4% increase between 2020 and 2021. I think a lot of specifying agencies are starting to require participation in the sample program rather than not necessarily full accreditation, but requiring that some sort of confirmation on their design work capability is ensured. And I think that's where we're seeing some of that growth. 20 to 30 samples in a program is actually pretty substantial. There are almost 1,100 participants in Gyratory. And I think when I took over the program a few years ago, we were around 800. So to grow almost 300 participants in the matter of 5 or 6 years is a pretty substantial increase.
Yeah, I'm glad you mentioned that because I think it's a mistake to look at our participation and think that's an indicator of spending on construction, for example, or transportation, because really it depends on what the states want to do or what the specifiers want to do. If they want to require proficiency sample program participation, you're going to see a big increase. Like we saw that with Oklahoma a couple years ago, right? All of a sudden they required all those laboratories that are producing material to participate. So we saw a jump there, but we have plenty of states that don't require anything as far as accreditation or assessment or proficiency sample performance. And that's something that I would like to see more attention paid to, because anytime you get a lot of expenditure in transportation funding, it really needs to come with some accountability and some way to measure the quality of it. And I think the proficiency sample program really gives you a good indication of whether you can rely on the results from those laboratories. States are having less funding to do their own oversight in some cases, and I think it just gives them an easy way, a little metric to use that can give them a little bit of confidence in their test results and in the material that goes out on the pavements. So that's a little side note on the quality and accountability part of all of this. Anything else related to Marshall Design you want to talk about, John?
No, I don't think so. I mean, I think, like I said, it was a pretty straightforward round. We saw a lot of normal distributions in the test properties, and I'd said I think it was a pretty successful round for the participants.
Finally, we're going to cover the Asphalt Mixture Super Pave Gyratory sample rounds 53, 54. You would just mention that that's the one that has more consistent increases. What's going on with that sample this year?
Pretty boring sample, if you want to call it that. Nothing really crazy. The target heights were right within specification, and the laboratories reported those results. And it looks like the standard deviations were consistent with previous years. So it was overall once again a pretty normal, successful round. This year, the design did not include mineral filler. It was just something where, when we batched the fine aggregate portion, we had a pretty high amount of passing 200 material in the fine aggregate portion. So we were fortunate to not have to use mineral filler in the design work. But it's interesting here that we actually had 10 participants submit gravity values for mineral filler. I'm not really sure how that happened, but the round that line item was suppressed, so it's kind of a moot point. But it was interesting to see that we had laboratories submit data for that anyway.
That does boggle the mind when you don't include a material and you get a result on that material. And I think attention will be paid to those laboratories that submitted data because we have a lot of questions about how that happened. And let me know what you find. One thing that, of course, we think about when we hear something like that is, are these real results, right? So those are some things that the accreditation program is going to be paying attention to. And if there are issues, we'll be following up with those participants. But it could be a simple mistake too. We will consider that. Anything else with this round?
Similar to what we saw with the Marshall and the Hveem, the air void ratio was a little bit lower than our target for the mixed designs from our end, but I think they were still within, a typical 2 standard deviation limit. And like I said, not that we use, our value is not a set value in stone. I just basically use it to reference how well I did when it comes to preparing the specimens. One thing that we added, I guess this is our second year for it. It's line item number 3. And the report, which is the dry mass of the bulk specimen prior to gravity testing. This was actually a suggestion from one of our participants to add this test property in the round. And we had a lot of questions about, why do you guys care about what the dry weight of the puck is before you put it in the water bath? And one thing that we've learned is that's a pretty good measure of how well the facilities are preparing their specimens. How well they're mixing, how well they're doing their butter batches, and it's a metric that we think is valuable to include because then laboratories can use it to help with corrective action processes for things like specimen heights or air voids or bulk density values. So it's totally random suggestion by some participants, but I think it's truly valuable for our customers to use and evaluate.
Okay, so I'm gonna, on Kim's behalf, I'm gonna throw the jargon flag on that play. So you mentioned butter batches. Just for those who don't know what that is, can you explain what that means?
Yeah, sure. So when we prepare the specimens or prepare the samples to send to everybody, we basically send double the amount of material, and you prepare essentially 4 mixture specimens, 2 for the odd sample and 2 for the even. Well, the first one that you prepare in your mixing bowl, you discard, and you only use that for your rice test. That's simply to allow the bowl to have a little bit of fines and asphalt on it. So that way you're hopefully getting the most accurate design or accurate mix out of your sample prior to you actually doing the compaction specimen.
Thank you, John. Now, Pete, I want to ask you about this because we were kicking this idea around. So this new data point comes out and it's available. And one of the things that we have to consider on the accreditation side is that something that we want to take action on if laboratories are receiving low ratings? What do you think, Pete?
Yeah, I think it's a great idea to evaluate labs for these, data points that are part of the underlying data for the final results being reported. It's a way for labs to identify errors that they would otherwise not know the source of the error in their final result. And if we evaluated not just this data point, the dry mass for this particular test, but the other masses involved in this and other tests, be a really great tool for the labs. And it would also help to eliminate those errors and tighten the standard deviations for the final results for those tests.
Is that like kind of showing your work when you're doing a math problem? Like if you're getting graded on the mass before, so it's not just like I got the right answer, it doesn't matter what, like, quote unquote right answer, but like I got the right result, so it doesn't matter what my work was before that, but this is kind of like showing your work. Is that what you're saying? Or am I wrong?
Yeah, it is like showing the work. That's right. Yeah. So for like bulk specific gravity, you could have up to 3 for the test in general, up to 3 masses that you determine and perform a calculation using those masses to get your final number. And if you could compare for this test in particular, the underwater mass determination. If you see that your underwater mass determination is way off compared to everyone else's, then you know what's wrong in your lab, and you can fix the balance, the bath temperature, whatever's wrong for that underwater mass determination, and then that will help feed into fixing your final result.
Yeah, I think you hit it there too, Pete. Like this parameter that we're specifically looking at with the dry mass. If you look at your results for your specimen height and you see that you're 3 or 4 millimeters below everybody else's and you're getting a 0, and you immediately look back at the mass of your bulk puck and you see the mass is 200 grams less, it's a pretty quick indicator that you may have a problem with your mixing and butter batching process.
Just to clarify, currently the AASHTO accreditation program does not take action on any of these underlying data points. Is that correct?
That one we are not taking
That
action
one.
on. I don't want to
Okay.
say that, some people would consider some of the results to be in that category that we look at. I'm not convinced that we are going to take action on that particular one. Pete still has to convince me of that. I think it's great to have that as a tool, like he was saying. But if we find that people are ignoring it, then I think we probably will lean on that a little bit more and take action, because that does indicate a compaction problem if they're getting low ratings. But the other thing I think about with bulk specific gravity is that is kind of a relative value, right? Like it's a ratio. So like I would anticipate if somebody's getting low ratings on that, they would also have low ratings on the other ones, and then an overall low rating. So I don't know that we're going to see a lot of interesting information coming out of that. So I'd like to see how it goes for a couple rounds before we decide if that's what we want to do. Now that's my current position on that, but we'll see what this looks like when we actually dig into it, and maybe it'll be convincing and we'll end up having a policy change. But with any suspensions that come out of proficiency samples, it takes 2 years of consecutive low ratings or lack of participation to result in a suspension of accreditation. Best thing that people can do out there to avoid that is to review those results. If you have a low rating, investigate it, take corrective action, and don't get a low rating next time. Easy enough to say, I realize, but you have to at least take those steps and do your best and try to correct those issues. And any other thoughts, gentlemen?
Yeah, John, something, that people might be wondering about. Why are their results being requested after 8 gyrations? What's important about 8 gyrations? Is that just the random points selected there?
Yeah, so using the AASHTO standard, you can calculate the density values at any point in the compaction process. And 8 was just what was selected to be an initial measure, and that's kind of it. It wasn't. We could pick it at 30 if we wanted to. It doesn't matter anywhere along the compaction process. It's part of the standard, and it's just a point that we selected.
Do we know, like, what the industry is doing in terms of an endpoint? We have 100 gyrations. Is there any desire from our labs to see a higher number there?
I haven't heard any, suggestions on adjusting that. I know in the past we did have the compaction at 150 gyrations, but that really has to do with traffic load and the design of the mixture in itself. So it's not necessarily a specific endpoint. It's just simply based off of the mixture design for the traffic load that's required for that project. It's really what it comes down to.
Yeah, it's a design parameter. But where do we get these designs? I guess would be one question. So we have this particular sample. Is this something you came up with, or was this derived from a mix that a state was using?
No, this is my own design. So throughout the process in the spring, once we get the material secured, I will go ahead and go through basically the AASHTO, I believe it's R35 mixture design process, and get the densities or the specific gravities of all the materials that we're going to use, perform the viscosity testing for the asphalt binder to set my mixing and compaction temperatures, and basically go through the entire mix design process and create the design and send it out to everybody. So it's like I said, that's why I like looking at those numbers at the end and comparing my values, because it gives me an indicator as to how well I'm comparing my mix design process and packaging and testing to everyone else. I'm going to rely on the 1,000 participants to tell me that I'm wrong, if that's a good way to say it.
Yeah, have any engineers reached out to you and said, "What is the deal with this mix? Like, where'd you come up with this crazy thing?"
Sometimes that does happen. So I try to, I follow as many of the parameters as I can to ensure that I'm producing a mix design that would meet a specification. But that doesn't mean I won't teeter on the edge, because like I said, I don't want to develop complacency. I don't think it's realistic for me to send a design out every year that is right around 115 millimeters and targets an air voids of 4%. And has a perfect VMA and VFA. That's not my goal. My goal is to ensure that I send a variety of specimens across the industry and, I'll have heights range down to as low as 112 and as high as roughly 117. I had a 111 one year, and I had laboratories lose their minds because people thought their compactors were not functioning correctly, because some laboratories were sending results back around 108 and 109, and that's below spec. So, I'll hang on the fringes, but I'm not going to try to go outside of the specification limits just to kind of save face a little bit.
But that's a great little nugget of information that kind of at the end of this conversation that I hope people hung on long enough to hear that, because I think it's really important for any of the customers of the Proficiency Sample Program to understand that that sometimes those samples that seem a little off, if you followed your procedure, you have nothing to worry about. Don't panic. Just follow your process and submit your data. And don't ask John about it. Just do your thing and see how it goes. But I know people get very nervous when it comes to proficiency sample results. So easier said than done, like a lot of these things. But yeah, thanks, John. And any last comments or questions from anyone?
Well, I don't know if anyone's interested in this, but there's also the gyratory program, and Super Pave Design is also distinguished from Marshall and Hveem in that there's not a separate air voids content in determination in the gyratory compaction program. So in the other two programs, the air voids are calculated from the max density and bulk specific gravity results. But in Super Pave Mixed Design, it's calculated from the compaction data. But I was curious if we had any customers asking about the air voids result not being included in the gyratory program.
I mean, the percent of max density at 100 gyrations is the air voids. You still use your bulk specific gravity and your Rice gravity to get that value at 100. So it's still an air void ratio. It's just that you're saying that it's at 100, gyrations. That's it.
Well, it is kind of funny though. I agree. That's always been considered to be a little bit of an anomaly about the gyratory process, is that there isn't a line item in the reporting for air voids, and it's almost like, okay, this whole design is based on volumetrics, and yet that's not that's not a report requirement to have the percent air voids. Like, it's not specifically laid out. So it is kind of weird if you think about it that way. I think that, Pete, is that what you're getting at?
Yeah, so I guess, in gyratory compaction, you have that percent of max density result in your compaction, and that's based on the specimen height, correct?
Yeah, it's just based on the specimen height after 100 gyrations, but the equation still uses the max gravity and the bulk gravity.
Okay, so you just subtract that from 100 and you end up with the same number.
Yeah, that's it. That's actually one of my checks in my mix design sheet. I calculate it per T312, and then I calculate the traditional bulk or the traditional air voids and double check that the math is correct.
So here's another question. Should we be looking at that final line item and holding it against labs accredited for the air void test, since it is mathematically the same?
That's a good question for the accreditation program.
I thought you were going to say that. Throwing it.
You like that punt?
Yeah.
PSP punt right one. There. That's what that is.
Yeah. So that's a good question, Pete. My only concern about that is that it is different. Now, it is granted, being accredited for percent air voids is kind of a silly thing, because it's just a calculation. It's about as simple a calculation as you can have. And it's more like, okay, well, if you're doing bulk right and you're doing max specific gravity right, then you're doing air void. You can perform this calculation. We could do that, but because it's not exactly what the percent air voids calculation is, I'm a little hesitant to do that, because if T269 and D3203 stated that calculation can be this too, then I'd say yeah, but I'm not sure if we should do that or not. And I'm not sure there's a lot of value in it either. Also, I'm not really sure if accrediting for a calculation has a lot of value, especially when it's that simple. So it's like really the bulk specific gravity and the max specific gravity results are what people should be paying attention to. And I think if you're a specifying agency, you want to look at that. So how's that for a non-answer?
Good non-answer answer, Brian.
Okay.
Gives
Good.
us a
I'll
lot
be-
to think about.
It is. It is a lot to think about. You're right. But well, we will consider that. Kim has a question.
You can finish your thought though.
No, I'm done.
Okay. I just wanted to let listeners know if they wanted to see general results of the sample round analysis for these samples that we were talking about, you can find those at ashtoresource.org/PSP/reports. And there are links on that page to the general results of a sample round analysis and a compilation of statistics. So if you're interested, if maybe you're not a participant in one of these sample rounds, but you're kind of still interested in what we were talking about, you can kind of see all of the information there. So I wanted to point that out.
All right. Thanks, Kim. And thanks again to Pete Holter. Pete, thanks for coming.
Thanks for the invite.
All right. And John Malusky, thank you.
Always, Brian. Anytime.
Yeah, and we will be. I'm glad you said that because we will be leaning on you periodically because I think these discussions are really good to talk about what's new in the rounds and to get that information out there. And Pete has another question.
Yeah, this goes back to Veeam.
This is just like an app meeting, by the way. When we get together, we'll have like 8 items on the agenda, and by the time we get to like item 5, Pete's like, I have a question about number 1 because he's like thought about all of the different angles related to that particular discussion, and he's ready. He's finally ready to have it. So go ahead, Pete.
John, I was curious. Texas Department of Transportation, they have some of their own proficiency sample programs, correct? I was wondering, do they have a proficiency sample program for the Texas Gyratory? And if so, I was wondering how our program compares with theirs.
To be honest, Pete, I don't know. I know that there are a lot of agencies out there who do have their own mini programs. I can't 100% say how they compare. So that's something that we would have to reach out to the industry for to try to have those discussions. I know that I have had discussions with agencies in the past about figuring out how to improve their operations and, do things the way we do. I've also had some of the states say, we've been doing this for 20 years. I think it's time that we go ahead and we just allow AASHTO Resource to take over. And, all of a sudden we see a flood of enrollments like Brian was mentioning with Oklahoma DOT. So it happens. So I can't 100% comment on comparison, but I know we're seeing a shift to allow us to do more of the workload for the agencies.
Yeah, that'd be good. And if you're a DOT and you're wondering about whether you should join us in our quest to provide the best proficiency sample program out there, you definitely should give it strong consideration. More data is better and more reliable when you're looking at statistically significant results. And we could probably figure out something to cover if there's certain items we're not covering the way you like. Reach out to John Malusky at jmalusky@ashtoresource.org and start that conversation. So everybody, thank you so much for your time. We are pushing it on our length of episode today. So thanks for hanging in there with us. If you have any feedback for us, let us know. Podcast@ashtoresource.org, or you can reach out to Kim Swanson or me, Brian Johnson, anytime you want. Hope you enjoyed the episode, and we'll see you next time.
Thanks for listening to AASHTO Resource Q&A. If you'd like to be a guest or just submit a question, send us an email at podcast@ashtoresource.org or call Brian at 240-436-4820. For other news and related content, check out AASHTO Resource's Twitter feed or go to ashtoresource.org.